This edition of our podcast is brought to you by 360 Health and Well Balanced Nutrition.
Welcome to the Health Geeks Book Club podcast. Listen in as Kristen Norton and Eleanor Russell review all those great health and wellness books you've been wanting to read or you have read and want to talk about. Here's Kristen and Eleanor.
Hey everyone. Today
Hey.
we are talking about a serious topic. I think we can all say that we've been affected in some way or another by cancer.
Oh, yes.
And we're going to review and talk about the book, The Cancer Code by Dr. Jason Fung. And I will tell you a little bit about the author in just a minute. But today we're going to start with some feedback from a listener out there.
Yeah. We were asking you guys to give us some feedback, tell us what you think, and somebody's doing that, and we're going to share one of them. So they wrote in and said, "You all are reading a lot of books on your podcast. You really are geeks." Yeah, that's what we said when we started this. Who's going to listen to this? Because we're really geeky. But anyway, she goes on and says, "I'm really interested in forest bathing. I heard about it a few years ago from a friend that did a long weekend retreat with a forest bathing leader. I think I have found a Facebook group in my community I'll be following. When you live up north, you walk outdoors, particularly if you're up in the Vermont area, and you're in nature. Not so much where I'm living now. I'm in a very urban center. There are lots of parks, and we try to do one nature event a week. The podcast made me think about how I can get my two granddaughters out in nature more often."
Oh, nice.
So I was really excited about that, and I hope that they're enjoying their outside time.
Yes, absolutely.
Yeah.
Well, thank you so much for sharing. And listeners out there, we'd love to hear your story as well.
Oh, absolutely. And we'll be reading them and sharing them because we want to spread this effect, on what is wellness, how do we stay that way, and if we read, we learn, and we do. So there we go. Now tell me about Jason Fung.
I like that. Yeah, so Dr. Jason Fung is the author of The Cancer Code, a revolutionary new understanding of a medical mystery. Now, he's also he's the author of the Diabetes Code and the Obesity Code,
Which I have not read, but I might.
I haven't read those either.
Mm-hmm.
So he is a physician and a researcher. Let's see. He's really into fasting. I know that.
Mm-hmm.
So we'll get into that a little later. But his work on fasting has been cited by CNN, the New York Times, Time, the Atlantic, Forbes, the Toronto Star, and many other media outlets. So he's getting attention.
Yeah, he is. And you know what I thought was funny? When I went to look him up, I couldn't find out that much about him. He's a nephrologist, which, is kidneys. That's his training.
Okay.
And he did his graduate, I don't know, he graduated from the University of Toronto. And I don't know about the medical school there, but I'm assuming there's a medical school. It just said University of Toronto.
Okay.
And then he did his residency at UCLA in internal medicine. So, I'm assuming he does, sometimes they put MD after their name, sometimes they don't. He's just calling himself in this publication Dr. Fung.
Yeah.
Yeah. So anyway, did you look at when it was published? That was the other thing. This is really current, isn't it? Copyright of 2020.
Oh, wow.
Yeah, so this is hot off the press, folks. This is a good one. And it is published by the publishing house is HarperCollins. Yeah.
Okay.
Yep. So it's gone through a pretty good review process, and he divided it into, 5 parts?
This is not a small book, folks. This is 312 pages.
It's a big, bad book.
Yeah, and then there's a thick reference section, too. So he really did his research on this. And I think that's his jam. I think he likes to dive into these issues and...
The complete story.
I watched an interview from him.
Oh, you did?
And it was an hour long, and the interviewee... Right? The person that was asking him questions was just kind of like, and he talked and talked and talked.
A real academic.
Yes. He was lecturing.
Yeah. Well, I kind of respond to that. So you and I are going to have an interesting conversation here because I got excited about this book because it is one of the medical conditions that I think scares all of us.
Yes.
We live in, if we want to live in fear of something, it's cancer. And we're seeing that in the United States, cancer rates are increasing and have over time. But cardiovascular disease is kind of plateauing maybe or reducing its rate. So we're seeing a decline in infections, except for last year with COVID. So this idea of, maybe it's a way to get us out of our life. We all have to die, right? I mean, my husband used to talk about that. He said, you're born and you die. Everybody's going to die. And so how you die, if you don't get hit by a truck, it's not a trauma. If it's not a heart attack, and then it's not an infection, well, something's going to have to take you out. So that's what we're looking at. It's what's going to take us out of here. And those of us that want to stay a little longer, like reading these books, to see if we can push that inevitable exit out a bit and have a nice long. We read the book about the centenarians, the blue zones. Where people live a long life. And so we spent some time talking about how can we have that for ourselves, a nice, happy, long life that we're engaged.
Yeah. And I think what's scary about cancer is there's just so many unknowns. Like we understand heart disease. We understand.
Maybe. Yeah. We think we do.
We think we do.
Yeah. We are making progress.
There's treatments and solutions. But with cancer, there's so many different types. Right. And a ton of research and money has gone into the treatment, yet there hasn't been the
gains that we would expect.
Exactly.
Yeah, right. It's how come. And that's what this Dr. Fung is saying. Hey, guys, we've been at this for eons, and why have we not made progress? And that's his story, and I got fascinated with the way he took us through it. But if you will permit me, he starts off with a little history lesson, right? Mm-hmm. And I love the history of medicine. I remember when I first thought about it, because I have friends who like to read historical fiction. I have other friends who like the war years, and they'll read all this stuff about military advancings and like the Prussian advance and Napoleon and but
you're
I get into it on the medical stuff.
Medical history.
Yeah, and when I first heard about, these primitive prehistoric people doing brain surgery, trepanation, they would crack a hole in somebody's skull and they would fix the problem, And so, but cultures have known ways to take care of people. They may sound brutal to us, but they did work. So anyway, this guy gives a little review of people like the Egyptian Imhotep, and he figured out that there were breast masses and solid tumors. And that was 2,625 BC. That's a long time ago. And then around 400, Herodotus wrote about inflammation and described it very carefully, and we still kind of agree with what he said about it. And then around 1000 AD, we got the bone tumor ideas that we could maybe acknowledge that they're there. There are tumors in your bones. They were identified. And then lymphoma, 2 million years ago, there are archaeological finds of jaws that have the evidence of cancer. So cancer has been with us for the eons. And people have approached it and tried to talk about it. And then Galen, the Greek, actually labeled it oncology. The study of cancer is oncology, and that's what our medical professionals talk about. But that comes from onkos, meaning swelling. And anytime you talk about a cancer, you put an oma on the end of it because that means tumor. So there's carcinoma, melanoma, lymphoma, glioma. So that's the terminology, and we've had that for a long time. So do you like history?
No.
Okay, so that chapter was not interesting to you.
Well, but no, so I will admit, this 315-page book I put down. I did not get through it all because it felt like a mix between a history book and a cancer textbook. But having said that, the history part I did go through, I found interesting. Yeah, I did enjoy it.
Yeah, because if we've known this stuff for so long, why have we not made more progress with our thinking? And so he brings up that idea of amnesia. it's like we get an idea and then it falls out of favor. And then it takes another whole discovery process to rediscover something they'd already known.
Right.
And I found that really interesting. But here's what they kind of came up with. I mean, to set the stage for talking about cancer, you have to say, what is it? And so what are the hallmarks of cancer? And they came up with some really, or he came up with a really succinct description of, we know that there is proliferation, or that it grows, and it evades the things that would suppress growth. There's signals in your body when you're growing. And when we were reading The Switch, we talked about growth, and we talked about repair, building and repairing. And autophagy, remember that conversation? That was really tedious.
Yes.
But it was an important concept that we were introduced to in The Switch. And then these cancer cells resist death, so they become immortal. And they just keep living, and they shouldn't. I mean, cells should die, but these just keep living.
And that's what defines cancer.
Well, and there's a little bit more. They can attract blood vessels. This angiogenesis, they can say, hey, for me to live, I have to have resources, so let's build some highways and bring me some food. So they know how to do that. And then they can invade other territories. They can move. And so they found out that, well, I've used up all the resources here. I've got a highway out. I'm going to the next place and sit down housekeeping and see how my life goes over there. So we call that metastasis. Many people who have an experience with cancer understand metastasis is advanced because the cancer's escaped from its original location and it's going to take over. And then the really cool thing that they figured out is that cancer cells can deregulate or change the way a normal cell does its energetics. And that was fascinating to me. And then they can evade the immune system. They can hide, like the sheep and wolf and sheep's clothing. Mm-hmm. So these cells are really, really smart. They are not dumb. And so as you get into looking at what cancer is, the challenge then, if we know what it is, how do we attack it? Because we don't want it. I mean, it's not compatible with my life. So that was the beginning of the book. And he set up 3 paradigms that I thought were pretty interesting, where we used to think cancer is excessive growth. And I used to teach that, cancer is a deregulated cell cycle. It just keeps growing. It doesn't know when to stop. It doesn't put the brakes on. And so he has a big conversation about that. Well, what causes that is some sort of what we call carcinogenesis, where you're exposed to something like radiation. We know that too much sunshine, they tell us cover your skin, you don't get melanoma. Or you can have an infection, which was really interesting when they discovered that infections can cause cancer. And do you remember the vaccine for the human papillomavirus that was coming out a few years ago?
Mm-hmm. Yeah.
They want every young girl to take this shot so that she doesn't get cancer of the cervix.
Well, I thought you brought up radiation, and I thought that section was really interesting on the folks who won a Nobel Prize for their work in radiation, but then their bones started falling apart, and they just had a really nasty end of life, which was unfortunate. But that was rather neat to learn about the history of radiation, the history of chemotherapy, how asbestos came about.
Oh, the asbestos story just rocked me. It's like, the Egyptians knew about asbestos, and they made napkins and fiber, and they just throw it in the fire and it would burn up.
Right.
I thought, oh, that's pretty cool. But then they found out that the people that were mining the asbestos had these lung problems.
Right.
And they were ignored, and over years and years and years. In the Industrial Revolution, that was one of those awful stories where they talked about, I think Fung says there's some immoral people. We've done some things that are not nice, and that was one of them. We continued to mine the asbestos after we knew. And that story about, did you find it where the company had the scientists that knew that it was bad? Yeah, here it is. Okay, it's the right to censorship. And we've talked about that before. Can I just read this a little bit to you?
Sure.
Because you said it was interesting, too. 1940, right? This is 2021, right? Leroy Gardner proved that carcinogenic material of asbestos when 82% of his experimental mice that inhaled asbestos developed cancer. Now, that's mouse research. It's not human. But, we're not going to have humans do that. This was more than a little concerning. Dr. Gardner was frantic to publish his new scientific results, but his sponsor, Johns Manville Corporation, reminded him about his contractual silence. Under the research agreement, the corporation had the right of censorship. The studies, which were originally undertaken to prove the safety of asbestos, had instead found the opposite. But for more than 4 decades, none of these potentially life-saving scientific results saw the light of day. Suppression of this vital information allowed companies to profit handsomely, which ties us back into Mark Hyman's book, that we really need to be paying attention to who's funding research.
Absolutely.
And what restrictions do they put on the findings. And so here's another example of damage done by not the open flow of scientific information.
Yeah, it's heartbreaking.
It is hard. It's awful. It is absolutely awful. And the chimney sweep story about scrotal cancer. Do you remember that one? The little urchins in London.
Refresh me. I do remember.
The burning the coal in London in the industrial age. As an ecologist, we studied the changing of moths because the suet on the trees, the moths adapted. Is one of the first stories of watching evolution in progress. But now here's the medical side of that story. That suet had to be cleaned out of the chimneys because of the fires. Your houses would burn. So they would get the orphans and get them to go up on the roof and go down the chimneys. And if they didn't get stuck or if they fell and died, it was a highly risky job. And they had little kids doing it. And the little kids that had exposure, if they survived the job, they were developing scrotal cancer. And it was all tracked back to this exposure to the coal tars and the soot. And they didn't take baths because why take a bath, if you're going to get dirty the next day? So they're just these dirty little street urchins. And it made me think of that Broadway play that has, it was a really popular play with Oliver Twist, maybe. Fagin was the character that took the little street urchins and told them to be pickpockets, and they were chimney sweeps and stuff like that. So, history. Okay.
Okay, so that was...
I digress. I could talk for hours on this because I really liked it and you really didn't.
So. Well, I didn't read it all. So, but those stories I did not know of before, and it was fun to know of them.
Yeah.
But tell us about the
paradigm. Okay, so he takes us on the evolution of the scientific and therapeutic ideas about how to address cancer and how we're not making the progress. So there was the idea that cancer could be started by lots of different mechanisms. It could be radiation, it could be infection, it could be inheritance. And so it did look, the second paradigm was that it was a genetic mechanism that gets disturbed. And so the idea that the somatic mutation theory came along, inherited genes didn't account for the amount of cancers we were seeing. You could inherit something, but the 80% of the cancers are coming from something else, which is disturbing.
That's a big percentage.
It is. When you're thinking about, I'm going to inherit this condition, 80% of the population is not, but so why do 50%, or 1 in 3, is that what of us are going to have cancer? Yeah, it's a high percentage. So the idea of preposterous reductionism was the other wonderful idea that came out of this, is that if we boil everything down to the molecular level, we'll be able to answer our questions. So he says in here, the somatic mutation theory is simple, compelling, elegant, and largely incorrect. Oh. And that was, you get radiation, it affects the nucleus, the genes disrupt and all that. So he says, in 2002, cancer researchers published an article in the New England Journal of Medicine observing the actual course of research on the molecular basis of cancer has been largely disappointing. Rather than revealing a small number of genetic and biochemical determinants operating within cancer cells, molecular analysis of human cancers have revealed a bewildering complex of such factors. So when they figured out, okay, the Philadelphia chromosome, they found that people that had the Philadelphia chromosome get cancer. Well, it's like 2 of the 3,000 cancers people can get are chromosomal. And so why are the rest of us getting cancer? What's going on?
It did not solve the problem.
No.
Or answer the question.
Yeah. And then when they say, okay, it's a 1 mutation. Well, no, it's a 2. It's a double hit. And then now it's a 4 hit. And so that didn't pan out. And he says the science that's been called process reductionism, reducing a problem to its smallest component, necessarily means missing the big picture. So then they move along to the paradigm number 3, which is what's driving that genetic mutation. And it was so cool. They decided, these medical people and the science people in the labs are the wrong people to ask the question. So they get an astrophysicist and some other kind of mathematician and said, tell us what cancer is. So they came at it from a totally different perspective. And it was one of the most fascinating stories in the whole book because it was a theoretical physicist and an astrobiologist. And what they decided to do was look at evidence-based medicine. And this is where the docs and these other folks are going to clash, because he takes on evidence-based medicine. And that's something that the medical community is really hot on right now. If there's enough evidence, then we're going to do what the evidence shows us. So he says, why is it such a big deal to bring the scientists from other fields to study cancer? Because doctors and medical researchers follow the dictums of evidence-based medicine. The status quo is considered to be fundamentally correct, and changing that understanding requires many peer-reviewed studies. Unfortunately, studies often take decades and millions of dollars, so progress is glacial. Old paradigms of disease survive even as patients die. So he is saying that evidence-based medicine works vigorously to defend the status quo against new ideas. Radical.
Well, it is a slow process to change evidence-based medicine. So, he said it's at a glacier rate.
Yeah.
I definitely agree with that.
Yeah, but that's radical. That to me is inflammatory, and it's going to cause a reaction from some people who are going to say no. But that's what he's saying through this story of history has happened over and over and over. People have come up with a good idea, and
it's so hard to prove that good idea.
The context says you're an idiot. That's wrong. You can't. You're just an idiot.
Yeah.
And so the idea dies, and it takes another time for someone to say, well, let's look at what they used to do. It worked, and why, and try to figure that out. So he goes on, and he talks about a whole bunch of people in here that I just loved. And he talked about the Procrustean bed. Did you read that part? You may not have gotten there. I know. But, sorry. I'm close to the microphone. I got so excited. This Poseidon had a son named Procrustean, and he lived in the bottom of the sea, and he would invite visitors to sleep with him. And if they were too long for his bed, he'd cut their feet off. If they were too short, he would stretch them. That kind of thing. And that's what this author says we've done with our ideas about cancer. We keep stretching our theories to explain the facts when they don't.
Okay.
And that's why they invited this other viewpoint in to look at this. And they came up with an ecological evolutionary biology approach. And that is what's the third paradigm. And it's exciting because what they're saying is cancer has been with us forever. All of us have it. We have an immune system that is going to attack it, and get rid of it. And that's what autophagy does. It says this cell's wrong. Let's get it out of here. If it overgrows, that's where the problem is. So you have the seed, that potential, and if the environment encourages that seed, it will proliferate. You're not going to stop it. And the cool thing about it is this thing called atavism, which means reversion to the archetype or the very first way of life. We were unicellular evolutionarily, and then something happened and cells collaborated, and then we became multicellular organisms. So you and me as humans are multicellular, but these cancers start behaving like a unicellular organism inside us, like an infective agent. And they are smart because they can grow, they can proliferate, they can move, and they can continue to cause trouble.
You say they are smart. I have this highlighted. Cancer is not a mindless growing machine. It is a dynamic, evolving species bent on its own survival.
Absolutely. And what he talks about energetically, which, I used to teach students about the Krebs cycle, and very few of them wanted to know about it. But the idea of aerobic and anaerobic respiration. And with our exercise discussions, people are aware of that. We want aerobic. Oh, you're going to go run. You're going to run for 40 minutes and you're going to hit that zone. Aerobic. You're going to do weightlifting. Tim, are you not going to do the aerobics?
You're not a runner, Tim.
I shall not.
But you've heard of it, right?
Oh, yes.
Yeah, so I think the general public knows about aerobic. And then if you're lifting weights and getting to that burn, you're going to the anaerobic. So, the general population is kind of getting an idea about tapping into the cellular energetics for whatever purposes, either building strength or burning fat, right?
Mm-hmm. And what is a cancer cell like?
And so the cancer cell, one of the things that they said is a hallmark is they can change or deregulate that stuff. So here's what I found fascinating. We breathe in oxygen from the atmosphere, and that oxygen is critical in our multicellular bodies because it's an electron acceptor. But by being able to accept electrons, it allows this biochemical pathway to produce ATP, which is adenosine triphosphate, which is our energy currency. It is storing energy to release to drive the rest of the work of our body. Okay, it's the most efficient. It gives us 36 of these molecules. Well, and that's what you teach. So that's why we're not anaerobic organisms, because this is so cool. Well, this guy says, yeah, but if you're a single cell organism, like a cancer, you can get 44 of your energy molecules out of the glucose. And I'm thinking, that's not anything I've ever seen before. And he showed me how it worked. You take a glucose and you split it and you run it through the Krebs cycle and you get your 36. If you go through the glycolysis to get into the Krebs cycle, you only get 2. So it's very inefficient. Glycolysis, anaerobic respiration is inefficient, but not really, because you got the pyruvate coming out, but you get lactate from the aerobic respiration, which we've said creates an acidic environment, which is not good for us, right? We have to blow that carbon dioxide out or our blood volumes and stuff. Oh, it's too complicated for this, and I'd like to get into detail, but I won't. The idea is the lactic acid, though, you burn it, you take it to your liver, you make some more glucose. So you're using the byproduct to generate the fuel to keep the energetics going for these cancer cells. So even as things decline, it's living in a resource beneficial microenvironment. So the environment of the cells, and that's what he gets to here in the end of the book, is he's talking about the ways the body tries to keep cancer at bay. And all of these therapies that were expensive, that were damaging. You poison yourself to kill the cancer and you lose your hair and you're weak and you're vomiting and all of your, the lining of your stomach. These are brutal therapies that people go through.
They are. And
so now we've got the idea of immunotherapy, where we're going to tap into the body's own immune system. And because it normally is surveilling, it's a surveillance system, it's going to find the bad cells. But how do we kick it up so that it finds more of them? And do we want to kill all cancer cells, or do we want to just have an adaptive therapy where some of them stay and most of them die? So we live in community with cancer. And that pushes that progression-free zone. When you get a cancer therapy, you can go into remission, right, and then it comes back.
Right.
And so they're trying to push that progression-free survival time out. But it's kind of disheartening, even after all this discourse and the hope for the immunotherapy, which is extremely expensive and nobody can afford. I mean, it's hundreds of thousands of dollars. Some people can afford it, but not the general person that gets cancer. And what he says is that's sort of immoral as well, because you tell a patient to hawk their house, sell all of their financial resources to pay for the therapy, and they get 2 months more of life, and they die, and their family is devastated financially. So is that a good thing to do to somebody? It's So the immunotherapy is the promise if we can get it to where it is. But preventing cancer, there's where the money is.
Yes.
What can we do? And so he says, here's the bottom line. we know that diet plays a large role in cancer, but cancer is not caused by a lack of dietary fiber. Cancer is not caused by too much fat.
And it's
Cancer
not
is not caused by vitamin deficiency. So what do? I mean, it's like, don't become obese, because in the obesity story, it's the nutrient sensors, the insulin, the growth factors, all of those things are going to increase your risk if you're overweight. That's a danger. So whatever you can do, moving your body, sleeping, breathing, eating, that is going to keep you in an optimum weight range, that's going to help you. And don't get diabetes. And if you have an optimal weight, you might not get diabetes. You can still get diabetes type 1, but reduce the risks. And that was how many pages? 300 and whatever. And we come up with, okay, how do I prevent cancer? Be healthy.
Be healthy,
yeah.
right?
Yeah, sleep. Don't be stressed. Don't do the things that are going to create a negative environment that allows the cancer cell to flourish and your own healthy cells to get those repeated chronic injuries, because it's the repeated sublethal injury to these cells that cause them to give up. And I can't keep repairing myself, so now I become damaged and I'm a cancer cell. Mm-hmm. So that's the idea, is keep as many of your cells healthy as you can for as long as you can.
So, and it goes back to self-compassion, stress management,
which is the environment,
getting out in nature, all of these things we've read about in the book, exercise, a well-balanced diet that manages blood sugar.
I think so.
Yeah.
I do think so. I think that the prevention is the story. It's not the cure. It's a prevention.
Yeah. So, well, thank you for the explanation of the cancer code and the flashback to Advanced Metabolism 101.
Oh, yeah. But you know what else?
The Krebs cycle and pyruvate.
Did you read about the guillotine, the breast guillotine?
No.
Oh, God.
I don't want to hear about that.
Oh, yeah. Well, he opens one of his chapters with the story about the celebrity that did the radical mastectomy recently, and I can't remember, Jolie.
Angeline.
Yeah.
Angeline Jolie.
Yeah. He started the chapter with that, but he said, way back, they used to do this breast guillotine.
Where they just
back in the 1700s, just chop them off.
Ouch.
Cut it out, win it out, cut it out. Which, removal of tumors is not a bad thing, but then if one cancer cell has escaped, it has the ability to proliferate. So, even that brutal therapy, back then they had no anesthesia. Can you imagine submitting to that? Oh, God.
Well, we've come a long way.
Yeah, I hope so.
The history of cancer and what we understand about it, how we treat it. And Dr. Jason Fung will walk you through it if you want to read the book. And if not, I think Eleanor provided a really great summary for all of us, because this is one book that, folks, I did not get through.
Yeah, and I don't think a lot of people will, but he writes very well, and he does give some good anecdotes. And if you like history, I think you will enjoy it, because he picks up the thread of the people that made a difference in the story and told you a little bit about their world and when they were thinking their thoughts. But at 360 Health, we base our whole focus is on prevention and trying to stay as healthy as we can, so that we push our risk factors down and maybe extend our health span in our lifespan, so that our disease span is minimal, if at all. That idea, I think I've told you before, I want to play tennis, go out for a backhand, and just exit the world. It's going to be hard for Tim because he's on the other side of the net, but for me, that's a good end to my story.
And at Well Balanced Nutrition, we also focus on prevention, and we call ourselves nutrition and wellness coaches, because we care about your well-being and all of the healthy habits that can help you feel happy and healthy. And we invite you to visit us at wellbalancednutrition.com.
All right. Well, I think it's a wrap on the cancer story. And whether we get into another Jason Fung book or not, we'll have to see.
That's right. Well, thanks for listening. Have a good day.
And opinions stated in this podcast are solely those of the contributors and are not necessarily those of our distributors or hosting company. This podcast is copyrighted, and no part can be reproduced without the expressed written consent of Kristen and Eleanor.